Okay, now we're going to talk about solving these trig equations if they are in quadratic form. Okay, so what if we've got one that looks like this? Cosine squared plus 3 cosine theta minus 1 equals 0. Okay, so not so easy because we've got a cosine squared and a cosine term. Well, let me ask you this. What if instead, let's just make it easier. What if we had this equation? Nothing to do with trig functions. Can I factor this as quadratic? I mean, I can solve it for sure. I can either use the quadratic formula, I can factor. So let's see, this looks like I can factor this as, can I factor this? I'm going to cheat. No. Okay, good. Didn't look like I could factor it. The numbers seem friendly, but I can't. Okay? But how can I solve it? I can always use the quadratic formula, right? I can say x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So what is this? 9 plus 4, so 13 all over 2. Okay, cool. So I'm going to get two numbers. I could get decimal approximations or whatever. Okay, so I know how to solve this quadratic. Well, all I've done, I'm just letting x equal cosine of theta, right? So what have I really done? I could say, I could write this as cosine of theta equals minus 3 plus or minus the square root of 13 over 2. Yeah? Well, this is two numbers, right? I could say, okay, cosine theta equals negative 3 plus square root of 13, just plus, over 2. And I could also say cosine of theta equals negative 3 minus square root of 13 over 2. Those are going to give me two numbers that I can, obviously these aren't on my equation sheet. So how can I figure that out? Well, I use my calculator. And let's figure out how to position this. Let's do this left one. Okay, so all right, I'm going to say minus 3 plus square root of 13 divided by 2 gives me this. Okay, so now I'm going to find inverse cosine. And actually, let me just see, they do this in radians. So let's just do it in radians. So this is still in radian mode. All right, so my inverse cosine of that is that value there. So my first theta is 1.26 something or other. Okay. So now let's do our thing here and imagine, okay, here's our cosine curve. What value did this give me? This gave me this value here. This was a positive number, right, that I solved for, 0.3. So this gave me, I don't know exactly what it is, like there, right? So I need to find a second solution for this. Well, let's see, if this is 1.26, this is going to be 2 pi minus 1.26. So 2 pi minus 1.26. There's my second solution, 5.02. There's my second solution for this equation. And now I have my other equation to solve. And let's see, I think you can see that kind of. All right, so let's say minus 3 minus square root of 13 divided by 2. And what do I get? If I find inverse cosine of that, anticipate what's going to happen. Error. Why? Well, there's nothing, I can't find an inverse cosine of something that's greater than, but outside the bounds of -1 to 1, right? Cosine is only defined from -1 to 1. So this has no solutions. And let's confirm, just because. So the first one we got 1.26, and then, yeah, 0.502. So this gives us no extra solutions, and these are only two solutions to that original equation. And let's just go back and make sure we answered what they asked. Solve this equation exactly for 0 to 2 pi. That's what we did. We got our two solutions here. Okay. All right, let's do another one. Solve this equation exactly. 2 sine squared theta minus 5 sine plus 3 equals 0. That looks overwhelming. Let's just ignore that and write it like this. Instead of, let's say, let x equal sine of theta. Right? Okay, well, this is still like kind of overwhelming. It's still a quadratic that we're going to have to maybe, can we factor this? Let's see, we're looking for things that multiply to 6 and add to -5. How about -2 and -3? I could write this as, use grouping. Right, I've just split this -5 into these two terms. I'll factor out a 2x, and I get x minus 1. And I'll factor out a -3, and I get x minus 1. Cool, these match. So I can factor out a x minus 1, and I get a 2x minus 3 equals 0. Right? Okay, so now I'm going to use the 0. I'm going to set each of these equal to 0. I'm going to say x minus 1 equals 0, and 2x minus 3 equals 0. And now I cannot escape the fact that I'm actually solving a trig function anymore. So I'm actually going to write this as sine theta equals 1, right? Sine theta minus 1 equals 0. So I just brought that over. And 2 sine theta equals 3. So I'll write this as sine theta equals 3 halves. Right? Okay, this one, and they just want me to solve this between 0 and 2 pi. I can do that. Sine of theta equals 1. That means that theta equals, and I'm just going to think of my sine graph here, right? Only in just one place. So sine of theta, that's at pi halves. Theta equals pi halves. And sine of theta equals 3 halves, nowhere, right? Doesn't happen. No solution. So this is my only solution, is pi halves. Yes, perfect. It's always reassuring to match the book. All right, let's solve this one exactly. 2 sine squared theta plus sine theta equals 0. Okay, so this is a quadratic, but look, there's no constant term. I could factor just directly. I could factor sine theta out of both of these and be left with 2 sine theta plus 1 equals 0. Right? Okay, so now I can set each of these, make two different equations. So let's see, sine theta equals 0, and they're asking me to solve this over 0 to 2 pi. So that's going to happen, and actually greater than or equal to 0, but less than 2 pi. So there's going to be two solutions. So this is going to happen when theta is 0 and when theta is pi. Right? And how about this? Let's see, if I bring the -1/2 over and divide by 2, where is sine theta equal to -1/2? Looks like I'm going to have two solutions for that. Right? I got those. -1/2. So let's see, if I look at my table here, where is sine theta equal to -1/2? I get -pi6. That is not in this range, right? So if I add 2 pi to that, I'm going to get 11 pi 6. Okay, and that's going to give me this solution right there. Now I need to find this one. Okay, well, this distance is pi6. So my other solution is going to be pi plus pi6, which is 13 pi 6. Or no, it is not. It is 7 pi 6. That's going to give me that solution. Okay. Okay. Let's do one last one that's in quadratic form. Just use new paper. What if we have this? Oh, and this is a graph of that last equation. Kind of cool. Okay, what if we want to solve this one? 2 sine squared theta minus 3 sine theta plus 1 equals 0. Kind of stressful. Let's just let x equal sine theta. Okay, so 2x squared minus 3x plus 1 equals 0. So I'm looking for things that multiply to 2 and add to negative 3. So how about negative 2 and negative 1? Does that work? Yeah. 2x squared minus 2x minus x plus 1 equals 0. Right, I split this into these two factors. I mean, you can also use, of course, your generic rectangle to do this, if that makes more sense to you. So what am I going to get? X minus 1 minus x minus 1. So I get x minus 1 times 2x minus 1. Okay, so now, so I can replace my x's with sine theta. Sine theta minus 1 equals 0. And 2 sine theta minus 1 equals 0. Okay, so sine theta equals 1. Sine theta equals 1/2. All right, and we're looking for solutions from 0 to 2 pi. So where is sine of theta equal 1 on 0 to 2 pi? That's going to happen at pi halves. And 1/2 is going to happen in two places. Right, the first place is at pi 6. There's that. And the second place is going to happen at pi minus pi 6, so 5 pi 6. Oops. So I'm going to have 3 solutions. And I think, yeah, that is the last example of that. So a lot of this is just factoring, you're remembering how to factor quadratics. And if you forget, you can always use the quadratic formula, right?